Okay, Tuesday of week 8.
I think it's 9.
Yeah, 9. Is it 9? It must be 9. Yeah. 8 was last week. Okay, and Thanksgiving. So this is our only class. So we're reviewing the markup and the margin. And if we have something that has a $15 retail selling price, the store acquires at $10 for their wholesale cost, then the $5 difference is both the margin amount and the markup amount. Those are two different words for the same subtraction problem. If we say $5 starting at the 10 and going up is what percent? So 5 is half of 10. That's a 50% change. And since we're starting low and going up, that's the markup rate. We could also say, let's look at what we're selling it for. $5 is what percentage of that? So 5 out of 15 is a third, so 33%. That's the margin rate. So that's going down. So the subtraction is the same, but the percentages, you get two different percentages based on if you're looking up from the lower number or down from the higher number.
I just want to make sure I have this right. For my margin amount and my markup, I have selling price. Is it divided by wholesale cost?
No, minus.
Subtract.
So these two here are dollar amounts, and these two here are the percents. Right? Amounts are dollars, rates are percents.
Can you explain margin rate again, please?
The margin rate?
Yeah.
It's where the business model of the store says that we will start with what we're selling to the customer, the sale price, and then we will use that as the original. So when the percent change is change divided by original, we're going to do the $5 divided by the 15.
Okay, thank you.
I'm not enough of a business expert to know which types of businesses typically have margin or which type have markup. I know a few examples. That would be another interesting thing. Okay, so let's keep going. So that was our vocabulary. We did some example problems last class with that. We're going to use them in more detail now, so we're not done with that yet. So, if you read the book from the class library about pricing, it's kind of thick. Right? Not that it's physically thick, it's just lots of different things they talk about. They sometimes talk too much detail. But it's very interesting about all these little tactics, like all the codes Costco uses for the ends of their prices, which ones are 59 cents, which are 99 cents, which are 00 and Y, and so on. We're not going to talk about that. So the tactics might be more interesting if you are in charge of Old Navy, but we're not. So we'll instead just talk about the big issues. So the first decision is if we're using markup pricing. Markup pricing uses that markup rate that we just mentioned. So the one that was blue, the percent going up from the wholesale cost. If we're using the markup pricing, then the selling price of something is the wholesale cost, and we could do this with one step or two. We could say that we take our $50 and we multiply it by this 40% rate. So what is 50 times 0.4? Well, 100 times 0.4 would be 40, so this is half of that, so 20. So we have $20 of markup amount. And then we would have to add these two back in. We have the $20 here, the $50 we started with. And we get our answer. Everyone with me so far? So that's just a little too slow. And I'm also lying, because it's not actually true that the selling price came out of that formula. So instead we're going to fix the formula using that 1 plus trick, which we've used several times before in other ways. So instead of by 0.4, I guess everything got too high. No, don't stretch. So instead of 0.4, we're going to do a 1.4, and that's this one right there. Then we'll get $70 right away, and not as the markup amount, but as the selling price that the formula really wants to give us. So if you hate the 1 plus trick, because some people do, then you can do 2 steps. But this, for most people, is just so much nicer. Okay, everyone okay with this so far? So that's the simple thing, but real life isn't simple. If no store is just going to take all of, well, at least no successful business is going to just take all of their wholesale costs, multiply them by the same 1 plus number, and then set their prices. Yeah.
Okay, so what I'm getting out of this is the selling price equals whatever the price is plus the percent that's being marked up.
You have to, if you're adding, you have to add dollars. That's what we did in the first of these. So we can't add a dollar and a percent together. It has to all be dollars.
No, I'm talking about how you did $50 times 1.4.
Right.
And you came up with $70.
Because the 1 keeps the 50 around, and the 0.4 was where the extra 20 comes from,
Okay.
and it puts them together. So the first wrinkle, why you can't just use that nice friendly formula all the time, is that some goods need to have a different markup than others. If you have a good that has a very high volume of sales, then you might want to mark it up less as a percentage. You will still get some good profit out of this because you're selling so much of it, and it might make people happy so they come back to your store more. So there are lots of examples we can think of where trendy goods are priced high to try and eke the most amount out, and reliable goods are priced with very little markup, so everyone goes to this grocery store to buy milk or whatever it is. And so the other problem is that the overhead costs might need to be distributed differently among the things you sell also. So there we go. So here's an example where in this gardening supply store, the best selling tools first use this 50% markup rate, but then they add an extra $5 because for the best selling tools, they can just charge a little more and it will still sell. So you do this one before I do it. the wholesale cost of this is 8. What's the selling price the store should use if it's 50% markup rate, and then add 5. I will go up and get the formula for you though, in case that helps. Is anyone going to fuss if I just put a +5 at the end? Because that's really what's happening here, right? Yeah. So it's going to be $8 times 1.5, and then +5. So 8 and half of 8 would be 8 and 4, so that's 12. Then we add 5, and we get 17. Everyone happy? Okay, so this is nice. Compared to all that simple compound interest baloney, these problems are much easier. You're over the hard part of math.
Say it like that.
Ready, Micha?
Yeah.
I can't tell.
I was just making sure I did it right.
Okay.
I came up with that answer, but I wanted to make sure I calculated it right.
So another issue is most things, when they're invented, cost more to produce, and then the technology matures a bit, and we get them cheaper. So here's a fascinating graphics. Make it bigger by clicking on it. No, that's the source it came from. Anyway, so you can kind of see on the screen how when telephones were brand new, less than 10% of the households in the country had them, and then people started getting them. Something happened in the 30s, and more people had telephones, and now almost everyone does. And one interesting trend is that the steepness of these S-curves is getting steeper as time goes on. And it took quite a while for even refrigerators to catch on, compared to color TV or all of these other ones that should, dishwashers are sort of the exception to the rule. And part of that is just that the economy has more or less been doing well since World War II. People can buy things more than before. And part of it is that technology is changing. The number of years it takes to get microwaves from hugely expensive to something everyone can afford doesn't take as long. So, microwaves, interesting article. Click here sometime. So here's a problem. Hector's Home Goods has electric pressure canners. There's more demand for the newer models that have more features, but the store also carries the older ones because some people don't want to spend that much. And so it has different wholesale markup rates, based on wholesale for the age of it. 60% for the new one, 30% for last year's model, and 20% for even older ones. So the wholesale cost of the newest model is 90. This problem is trying to trick me. Do I need to use all of the numbers? Which of the percents do I care about? Just the 60, right? That's not part of the problem. That's not part of the problem. So 9 times 6 is 54, and another 90, so 144. Did you make that right in my head? That look a little more like a decimal point. Okay. What else could make pricing interesting? Well, a business can bundle items to smooth out the effect. So conventional lettuce is sold at a very high volume, and the store makes almost nothing. And organic spinach has a much greater margin. So in this store, romaine lettuce has a 10% markup on 70 cents per pound. Organic baby spinach has a 70% markup, and it's $3.20 a pound. So how many pounds of the lettuce must be sold to earn the same markup as a pound of the spinach? What's the first thing I should find in this kind of twisty path of questions and things?
How much each one takes?
So, okay, so you need first the lettuce. Is that what you're wanting? So the lettuce has 70 cents times 1.1. My brain is turning off, so I'll cheat and use a calculator, even though that's embarrassing. Okay, so I've used the formula twice. Now what?
Divide. How much the lettuce goes in the spinach?
Not quite. I need one more step first. I've led you in the wrong direction to see who would notice. I'll give you a hint. This is the selling price. Except this one moment. Edit. So we're not asked to compare the selling prices. We're asked to compare the markups. Markup amount. So what's the markup amount for the lettuce? 7 cents, right? And what's the markup amount for the spinach? So that's what we're actually needing to divide by. So, yeah, 2.
So you do the 544. It's essentially the 320 times 0.7. So you can get that 2.4 and then divide it
32 times. So obviously the store wants to encourage people to sell spinach because they're not earning much at all on the lettuce. So if they have some sort of mixed green area or something like that, whatever interesting thing they do to say, buy more spinach. There's an article, if you're interested, the good, better, best pricing is a similar kind of thing. Okay, anyway, that was the markup. Different issues to think about when charging markup. You could also have margin pricing. So going back to our first slide of the day, what if we are considering not going up by a 1 plus amount, but going down from the more expensive one using the margin rate? What does that look like? Well, the first issue is 1 plus doesn't work anymore. Plus makes things bigger. So if we're trying to figure out how to get from 15 down to 10, we're not going to multiply by 1.33. Right? That would get even bigger. So what we're doing is we're saying that the 1 keeps the 15 around. And then we need to subtract a third. So we're doing 1 minus the 0.33. Does that make sense? That's a little more awkward because I'm no longer able to just write a 1 in front of the number like we've been doing for compound interest in other cases. So what's 1 minus 40%? The 40% is the same as 0.4.
0.6.
0.6. So let's see, 5 times 10% is 5, 6% would be 30. Doing that right? So if that's too much to do in your head, if that makes you feel like on the stress of a math final you're not going to subtract 1 minus 0.4 without a mistake, then you can also write it as parentheses, because you all have calculators that handle parentheses, no problem.
I like it that way.
So whatever works for you. If you like the first one, this note here is saying, in other words, the gardening supply store can only stock goods for which their supplier is only 60% of their retail selling price. So if it helps you to think about the 60% in that way. But it's a little tricky just because the problem gives you a number, and that's not the number you need right here. You have to do a little 1 minus thing. But still, as formulas go, that's not a bad formula. So that's what margin pricing is like. And again, if you would price everything in your store using that formula, it would be nice and simple, and you'd go out of business. So what are the complications? As before, you don't want to be too consistent. So loss leaders happen with both markup and margin, and they're the things that try and get people into your store, because you might not make much money, or you might even lose money. And perhaps the most famous example if you just search internet about loss leaders, is Costco. Has everyone heard about this, or is this news to you? So, Costco sells these rotisserie chickens, about 60 million a year, which boggles my mind. And each chicken is sold at about a 57-cent loss. And I'm not sure from the article I got this from if that loss is just compared to the wholesale cost of the chicken or if it includes the paying the employees to actually cook the chicken. Because this is prepared goods, it's not just something in a box. So it might not quite be what we're talking about. But anyway, what's the total loss for Costco from all these chickens? What do I do with these numbers?
I would times 60 times the 57 cents.
Your intuition is correct.
And then divide it by a year.
It is per year. I'm missing an important word. What word am I missing? I can put a dollar sign on things. The million, yeah, this is not just 60, it's 60 million. So my label isn't just per year, it's millions per year, right? Remember we did the unit analysis where units would cancel out, so nothing's canceled at the millions or the per year, it's just flowing through the equation. So yeah, $34.2 million a year this business loses on chickens. So, but they think it's worth it. I have a funny story. I went to Costco once, and out front, a woman that appeared to be certainly in financial trouble, maybe even homeless, came up and asked if she could walk with me into the store because she doesn't have a Costco card. She wanted to buy one of the chickens. So I said, okay. So I do my shopping, and she follows me around, and we chat. At the end, I pay for my things, and she gets her chicken. And the cashier says, you're not supposed to really let people mooch off your Costco membership like that. And so I said, well, she told me while shopping that her plan was to take the bus to and from Costco to get the chicken. So if your plan for the day is to take the bus to Costco to buy a chicken and then take the bus home, then I'm not sure I can do anything to make her life better or worse. Anyway, okay, product maturity. So this is kind of the opposite. Instead of an S-curve going up with how many households have microwaves, this is that thing we talked about last time where the iPads, when they're new and hot, cost a lot. And the cost goes down as people aren't willing to pay as much anymore. And eventually it settles on what's called the penetration price. They've penetrated the marketplace. So this isn't a bad thing. People that are really excited to have the very first whatever iPhones can get their excitement about that and show off. And things often cost more right at the beginning. We talked about that too. But if companies do this too much, they get bad PR. And Apple has had that happen a few times. So. Yeah, let's do this on a new page. In November 2006, the new PlayStation 3 was $500. During the next 3 years, the selling price was lowered in steps, and eventually the penetration price turned out to be $180. And if the wholesale cost is $120, and I confess that number I'm just making up because I have no idea. The other numbers I could find from searching the internet. But let's just imagine that the wholesale cost is $120. Then how much extra margin did Sony get from skimming? What's if we divide the larger margin by the smaller margin? It's giving us our instructions right there.
So the margins would be the dollar difference, the dividing, do you divide or do you minus?
500 divided by 180.
So larger margin, smaller margin.
So you would just take 500 divided or minus 120?
So 500 minus 120. Everyone see why it's not minus 180? Yeah, the wholesale is the 120. So this is the selling price minus the wholesale cost with the bigger selling price.
And what is this called? What'd you call it?
So margin amount.
Margin amount. Okay.
It's amounts if it's dollars, it's rates if it's percents. So 500 minus 100 is 400, minus 20 more is 380. What's the smaller one going to be? Yeah, the 180 minus the 120. So 30 divided by 60, or 380 divided by 60. So by skimming, they were getting more than 6 times as much margin in the beginning. And again, that's not real. I'm not sure what the wholesale cost of these is. We're not sure if they actually cost more to produce in the beginning. But just as like a ballpark, we're just learning about this. Questions about that one? The tricky thing here is just to do what it says. Divide the larger margin amount by the smaller one.
And then you do 380 divided by 60.
Mm-hmm.
Okay. 30% markup. Difference.
Yes, if you wanted to write it as a percent, you'd have to rip-lop and do that. Okay, what else about pricing? There's bundling too here. So this one it'll be a good review when I see you again after Thanksgiving. Use the same.
Could you review a problem from saving for retirement?
Sure. But we're almost done here. Let me finish this. And then we'll be done. So adaptive pricing, or dynamic, is when you're not doing these formulas just sort of once, putting the price tag on the thing and it's done, but you're changing it often. And there's 2 famous ways of doing this. One is to constantly monitor what people are doing. So this cute picture has when the price of something changed during the day on different online retailers. And maybe this was predictive, or maybe they were actually measuring how many people were logged into their site at different times of day, and when it got to a certain number, things would change. I don't know. The pricing book has more examples of this, including there are some parking meters now that change the price based on how many parking spots are full around them.
That's shady.
So. The other thing is called A/B testing. And this is when multiple versions are sold with different prices just to see which sells best. And you can get into legal trouble for doing this wrong, but you can also do it okay. So if you're interested in pricing, read or search about them. The last thing, which I'll just mention, and then go back to those review problems, is when we're talking about restaurants, then the formulas are the same formulas basically, but they look a little different. So let's see what happens. In the desired profit method, we're going to do the same thing as the wholesale markup. We're going to take our food and the labor and the other things and multiply them by the 1 plus the scale factor, just like we saw before. The only difference, I have to shrink it back so that it stops wrapping around annoyingly, is when we're done, we divide by how many servings the food costs. Because in the kitchen, when you make a giant vat of minestrone soup, no one buys that whole thing all at once. So if you just made 40 servings of soup, you divide it by 40 or whatever. So you're finding the cost per plate, not the cost per big thing. So a little bit of difference, divide by servings at the end. For some businesses, it doesn't make sense to keep track of the food and the labor and the other for each thing they make separately. Everything is about the same, with how much of it is labor, how much of it is other stuff. So those businesses will say, now I'm going to make it big again so you can see. We're just going to treat the percentage that's food as a scale factor. Maybe 25% of our cost is food. Maybe 30% of our cost to run the business is food, whatever. And then just like yield percent, we'll go backwards and divide food cost divided by the scale factor and figure out what it is. So if 30% is food and it's $100, you do 100 divided by 0.3. And you have $333.53 was how much it cost to actually put together your whatever it is. And at the end, divide by servings again. So we'll do examples of those next time, but just so if you wanted to rush ahead and do the homework over the big weekend, then these formulas, plug things in, they're not that bad. There's example problems. Discount, I don't want to talk about at all. That's kind of where we'll start next time. Let's look at the homework though. Come on. So, in your random problems, the store buys it for this and sells it for that. What's the margin amount and the markup amount? How do we do this?
Selling price minus wholesale price.
Yeah, you're just subtracting. And it's the same answer for both. Because they're the same thing, just two words for both. So that's just to make sure you're not tricked by having two words. And then margin rate, here's the number, markup rate, here's the number, and you plug it into the formulas.
So the margin amount method is always you divide the smaller margin by the larger margin.
I'm not sure what the margin amount method is. To find a margin amount or a markup amount, you're just subtracting the difference between what it sells it for and the wholesale cost of this machine. Okay, then you've got ones that look like the ones we just did, except for the restaurant meals, which we didn't do our examples yet. And then at the very end, we have the discount problems. For most people, these are the hard ones, which is why I don't want to try and do them when I'm rushed right now. Down. In the ones to turn in, you just have a whole bunch of different ones, and I handed this to you last class, so that's not a surprise. My wife was realizing I used the same G name twice, so this is now Giselle, whereas in yours it's something else. But that's okay, I just changed the name. Okay, review problems. Which review did you want to do?
I had asked by S76
Oh.
the scan for retirement. Yes.
This one. Oh, okay. We haven't done much with annual effective interest rate because it's just not that important. But it's good to know. So this problem is missing its principal. We have compound interest, payments are happening monthly, but it's not telling us how much is invested. So instead it's saying how much it hurts my wallet isn't really 18%. It's going to be a slight bit more because whatever interest I have to pay in January, I'm going to pay more interest on that in February. And both of those I'll pay interest in March and so on. So when I divide the 18% equally into the 12 portions, then they don't quite come back together to make 18%. When they come back, it's a little more because of compounding. So the trick to this is to just assume the principal is 1. Do all of the setup for compound interest because we always do that. Okay, so I'm just going to say the principal is $1. It doesn't tell me that, I'm just making that up out of the air. All I need is something to compare to see how much this is bigger than it started. It's not going to give me an end result of $1.18, it's going to be a tiny bit more. So if I'm comparing it to the principal, I'm just going to pick the simplest number I know, which is 1. Okay, the total amount, that's what we're solving for. The rate per payout, it's 0.18, and then we have to divide by 12 because it's monthly. What's my number of payouts? How many years am I doing this? Yeah, I want to figure out over 1 year, how much does it really hurt my wallet? So everything is in month, it's compounded monthly. I'm happy, I'm ready to go. Plug it in. And I get whatever that is, 1.015 exponent 12. Okay, I'm not rounding to dollars and cents because it's not that kind of problem. What's my actual rate of increase?
1.5618 over the 18%.
Yeah, so this part here, let me get a new color. This is 19.5618 so on percent.
What happened to that other one?
What happened to this one? This is the one I started with.
Oh.
But because I picked, remember I got to pick that, I picked one so that the cents I could turn into a percentage. Right? This is just rip-wop. Going right into the percent. So I'm going to round my answer. So let's say 19.6%. 19.56%. Whatever you want. So when the credit card says 18% annual interest, I mean, yes, it is 18% annual interest. But to your wallet, it feels like 19.6%. Because whatever you pay as interest in January makes more interest. If this was too much for you, go back in the lecture notes, and there's like a formula that says let's plug in the 1 for the principal, and when we're done, we'll subtract 1 from it. Someone has sort of automated this process as a formula. We have a minute. Do you want to do one more review problem?
We do 80.
We've done 80, the Archer Queen.
Oh, yeah, I wrote that down.
Okay, well, happy Thanksgiving weekend. If you need more books to read, because you have time to read, get them before you go home. If you haven't, this one? Sure. If you haven't done any big problems, or not enough big problems, consider doing some of that before I see you again. And have a good weekend.